welcome to this Maths Made Easy video on partial fractions. And to start with, let's just discuss the different types of partial fractions. Now the most basic example here is a fraction with two linear terms. So for example, we could have 5 over x plus 1 times by x plus 2. We could equivalently write this as a over x plus 1 plus b over x plus 2. Okay, so that's the most basic case there. The next type of partial fraction we can have is a fraction with three linear terms. So for example here, we might have something like 3x plus 4 all over x plus 1 times x plus 2 and finally times by x minus 1. And we could write this as a over x plus 1 plus b over x plus 2, and finally we could write this as our final part here as c over x minus 1. Okay. And finally, moving on to our most complicated example here for partial fractions, and that's a fraction with one linear term and a repeated term. So what do we mean by that? Well, for a fraction with one linear term and a repeated term, we could have, for example, 2x plus 1 over x plus 1 squared times by x plus 2. Okay, and we could write this here simply as a over x plus 1 squared plus b over x plus 1, and finally we've got c over x plus 2. Okay, and that gives us the three different types of partial fractions that we have. Moving on now to express this fraction here with three linear terms in the denominator as partial fractions. And to start with, what we'll do here is make sure we can identify the correct form here. So as this has three linear factors in the denominator, we can write 5x plus 1 over x minus 1 times by x plus 1 times by x plus 2 in the form here, and what I'll do is I'll use three different pen colours to identify this clearly. So the first term here, or the first partial fraction, is going to be a over x minus 1. And again, if we just change our pen colour here, my next partial fraction will be b over x plus 1. And finally, we have our final partial fraction here of c over x plus 2. Now here, we've got it in the correct form, so all we need to do now is get this part here, the right hand side, over a common denominator. So in that case here then, all I'm going to do is simply take a here and times it by the remaining denominators. So that would be a times by x plus 1 times by x plus 2. We'd repeat that here with this b, so it's going to be b times by x minus 1 times by x plus 2, and finally we repeat that with the c here and times by x minus 1 and x plus 1. So in total then, what we're going to obtain here is a times x plus 1 times by x plus 2 here. Okay. Doing the same with the b here, we're going to obtain b times x minus 1 times by x plus 2. Okay, and finally for the c here, it's going to be c times by x minus 1 times by x plus 1. Now as we've acquired this over a common denominator, which this denominator is x minus 1 times by x plus 1 times by x plus 2, in that case, this part here, the numerator for this right hand side, will simply be equal to the numerator of the left hand side. So this is going to be equal now to 5x plus 1. Okay. Now here, all I'm simply going to do is use substitution now to identify the values of a, b and c. And when we use substitution, what we want to do is substitute a value in such that it eliminates at least here 2 of the variables. So in that case, for example, if we let x equal -1, so we let x equal -1, well in that case, that would be -1 plus 1, giving us 0 there, so the a would disappear. And repeating that here, with this x plus 1 here, again substituting -1 in, we're going to get rid of the c here. So that just leaves us with our b here, so all we need to simply do then is substitute -1 into our brackets here, and substitute it into the right hand side here. Well in that case, we obtain -1 minus 1, giving us -2, and then -1 plus 2, giving us 1 there. So we obtain -2b, and this is going to be equal now to 5 times -1, giving us -5 plus the 1, giving us -4. So -2b is equal to -4, so therefore b is equal to 2. And we just repeat this now 2 more times to obtain a value for a and a value for c. So here, if we let x equal 1, then in that case, what we're going to get rid of here is our b term. That's going to be 1 minus 1. And same here, we're going to get rid of the c. So in this case, we're going to obtain our value for a. And again, just simply substituting our values in here. That's going to give me 1 plus 1, which is 2, times by 1 plus 2, which is 3. So we obtain 6a, and that's going to be equal to 5 times 1 plus 1, which is 6. So therefore, again, just solving for a here, we'd simply divide by 6. So therefore, a is equal to 1. And finally, we just need one more value here, and that's the value for c. And here, if we let x equal -2, we eliminate a and b. So if we let x equal -2, then in that case, all we need to focus on here is this c term here, multiplied by these 2 brackets, and 5 lots of -2 plus 1. Well, in that case here, we obtain c. So this is going to be -2 minus 1, so that's going to be -3. That's going to be times by -2 plus 1, which is -1 there. Okay. And this is going to be equal to 5 times -2, which is -10, plus the 1, giving us -9. So therefore, what we've obtained here is 3c is equal to -9. So therefore, c is -9 divided by 3, giving us -3 there. Now here, all we simply need to do now is actually express the original fraction that we started with as partial fractions. And we're going to use this form here that we started the question with. So therefore, if we write this underneath then, 5x plus 1 over these 3 linear terms here can be written, and again let's use the correct colour here. So this is a over x minus 1. So a is simply 1 here. So in that case we just write that as 1 over x minus 1. Moving on to the b here, b over x plus 1. Well, in that case, the b here corresponds to 2. So we write that as 2 over x plus 1. And finally we have c over x plus 2 here. And notice that c corresponds to this value here of -3. So if that's -3, in that case it's going to be -3 over x plus 2. So just be very careful there for the minus sign. And like we can see then, that gives us our solution there. To this example here, we're expressing the original fraction as partial fractions. Just one comment to make here to finish with is we just have to be aware that a, b and c may not always be integer values. You could obtain fractions, for example, here, so don't be alarmed if you do obtain fractions when solving here to express an original fraction as partial fractions. And to finish with here on partial fractions, we just want to make a few closing comments. Now you need to be aware that you might need to combine the method of substitution and equating coefficients for some examples. So an example where this would be necessary is a fraction with a repeated term in it. Okay, so in that case you would need to use the method of substitution and equating coefficients there. Just simply using the method of substitution would not be enough there. You also need to be aware that given a fraction that's not already been factorised, for example here, in that case it may be written, for example, as a quadratic or a cubic, then in that case we need to be able to factorise that expression. It's always worth looking out for the difference of two squares as well. That may help in terms of simplifying our fractions there. So that concludes this Maths Made Easy video on partial fractions.